All right. Our next presentation will be by Don Sizemore of the Odum Institute at UNC-Chapel Hill. And I guess also we're going to have Mike Conway, now from the NIEHS, and Tony Edgin from Sizemore, which is out in Arizona. The talk is entitled Discovery Environment and UNC's Implementation of a Community Edition.
Good afternoon. Really quickly, by show of hands, who all here is familiar with the Sizemore discovery environment? Has anyone used it? Is anyone interested in it? We've implemented several different instances of it. How am I doing? Okay, I'm getting the thumbs up. At a high level, here's the architecture. It doesn't really compare to what Clarice showed this morning, but most of the internal Sizemore-specific services are in Kubernetes. Uses console and Vault, as you see. The computation is handled in Docker within Condor, and to bring this, make this specific for this conference, all the data is stored in iRods. If you were a user and you went to sign up, which by the way is open, you'd see something like this. By default, you get a data window. That's where you upload your data through HTTP. The limit is 2 gigabytes. Beyond that, you need to go into iRods directly. There's an apps window. It's kind of blurry, isn't it? Oh well. You'll see in greater detail in the next. There's some basic file editing, which can be handy for viewing and editing should you need. That's down in the bottom left. And your results window from jobs run will show in the bottom right. Something that you as an end user would not see is the admin interface. It has a name. It's behind the YouTube censor bar there. But all computation is handled within Docker. So anything that can be Dockerized can be requested by a user, vetted by an admin, and approved as a tool within the discovery environment. Once you have your tool approved, you can upload your data and start to stitch together a job, which in discovery environment is stored in JSON. This is, how blurry is this? I should have made these, okay. That's what I get for doing screenshots on a Thunderbolt display. This is the interface you would use to construct your job. The most basic example that comes built in with Sizemore is word count. You feed it a file, it sends you your output. You can select any number of input fields graphically. The real art is in making it do what you want it to do after repeated runs. If you were able to read my results, you'd see a lot of failed, 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 succeed. The nice thing about jobs is that they can be stitched together in workflows. The nice thing about doing jobs and workflows in Sizemore is that they can be shared with other users. It does Dropbox-style public links for file sharing, but in Odum's case, I'm going to skip. Our archivists provide third-party independent verification of our journal research, and they spend a lot of time fiddling with some researchers' data and somebody's scripts and getting the right Python modules and the R packages. And if these jobs were already prepackaged and could be shared in some way that our archivists could run easily, it would save them a lot of time. Our other use case, you saw presentations from people at RENC about big data. And on campus, we have people who will help a certain number of researchers who have pretty big data. But at the Odum Institute, we provide qualitative, quantitative, and survey method walk-in support for student research. Graduate students and faculty, anyone is welcome. And the need that we see very often in the Research Hub, in the library, is for medium data. Data that does not really warrant HPC, but is too big to run on some student's laptop. So we're really interested in the community edition of Discovery Environment, which is coming end of summer, I hope, because it's going to offer interactive jobs. and it may be tomorrow, but I've seen it. It works. The nice thing is that we would be able to offer to anyone who signed up, say RStudio or Jupyter Notebook or some other interactive job in the structure of the discovery environment, so the data would be staged, offered up graphically, and when the job finished and the container goes poof, all the data and the results, even the Python checkpoints, right, the notebook, go back into iRods for the end user. So we're looking forward to the interactive version. We have the non-interactive stood up now, and Mike's going to tell us about NIEHS.
Yeah, so Don and I worked on this for a while. The genesis of this interest came out of our work with the DataNet Federation Consortium, and that's kind of what I wanted to talk about. So, I started out at the DICE group working with Regan and Raja and Wayne and the crew on iRods, and then and that actually started with the U.S. National Archives is where we were first oriented. I alluded to that a little bit yesterday, and then from that we became involved with the NSF DataNets project. So Regan and Raja, in collaboration with folks like Nirav and folks from all over the country, worked on what was called the DataNet Federation Consortium. And so a lot of the things that we see and talk about, this is ground that had been covered in the DataNets projects. This is where I started seeing a lot of this shift from data preservation and OAS towards cyber infrastructure and the support of data-driven science. And all these principles are really related, and what we saw was honestly the folks at Cyverse are super sharp, and they really had been pioneers, I think, in taking these principles that were coming out of projects like the DFC and other projects and actually doing them in production at scale. So a lot of the ground, for example, that we're starting to tread at NIEHS is really ground that folks like Cyverse have been sort of operating in production for some period of time at a pretty impressive scale. And so, kind of want to alluding to yesterday is this notion that we could really start thinking as developers and architects about a language, about patterns that really constitute sort of the technical underpinnings of what we vaguely call cyber infrastructure. And, so that's really what I wanted to do here. And so, the DRY principle is that we should not be repeating ourselves. We've had a lot of conversations about things like metadata templates. I've seen plenty of slides that are talking about notification systems. We see the patterns that Jason and crew are identifying for compute to data and data compute. Well, a lot of this stuff has already been done, and I at least want to say, how can we, through the iRods consortium, start comparing what we're doing, start trying to create a common language about these things, start identifying fundamental pieces of architecture that can exist either in iRods or exist around iRods that sort of constitute full production cyber infrastructure. So I was actually really excited to make the shift over to NIEHS. So I kind of am now in a mode of eating my own dog food in terms of working on one side of the fence, trying to produce software sort of within the iRods community, to now actually trying to stand up production systems and stand by them as they run at NIEHS. And I think it's a really interesting time as a lot of these concepts from things like DFC have transitioned into running production systems that all you guys are now building and running. And it's still a case where oftentimes we're pioneers in this field. There's a lot of lip service. There's a lot of vendors that say they have solutions, but really it ends up often coming from academic research projects from the open source community. So we're in a kind of an interesting phase. And so this is really what I wanted to get across as a point is we have what's in iRods, and is sort of becoming very much solidified due to the incredible efforts of folks like Jason and Terrell and crew. And then we have a lot of very interesting and robust site-specific deployments of a lot of technology, and I am really trying to get after these middle bits, as we call it. So what are the middle bits, and what can we learn from these site-specific deployments, start talking about as patterns, and start transitioning into either core capabilities of iRods, or start identifying sort of a regular ecosystem of open source software and open source and open APIs that we can use to start crafting these middle bits in a more repeatable and robust fashion. And, you know, I mostly have this slide maybe for folks to check out, and also as we start talking about iRods in future consortiums, I really like this idea that Ton was mentioning about hack fests to start building some software. And you know, for us, even though we you could either take all of DE and run it now with the community edition, but you can also learn so much from what these folks did. And I just wanted to provide these links here so you can look at their API. So they have a pattern of an API gateway, which is a very common pattern in microservices, where they lay out all the endpoints, so you can really get a good view of the kinds of services in terms of a REST API that sort of constitute robust cyber infrastructure that encompasses both compute and data management. And also, you know, we're starting to play, as we're working with Metalinks, they have their own database, and we're starting to leverage that with this notion that there's other kinds of information that's not in the iRods catalog. Some you can put into iRods as AVUs, but there are other things about cyber infrastructure in terms of a schema, the kinds of data you keep in a CI system, that you can observe by sort of mining the way that they've developed their sort of ancillary data schemas. And I know that we can do this with all of our other systems that we've seen demonstrated. So as we start talking and maybe hopefully transitioning to more hackfests, more technical discussions and sort of dissections of existing systems, this all goes towards this continuing process of trying to have a sort of discipline around building cyber infrastructure that is common among, you know, folks who are doing software development or architecture. This is what DE does that I think is so interesting. And you know, so what they did is they really found that sweet spot between compute and data in cyber infrastructure. And I think I need to wrap up here, but the whole notion here is you can have different researchers, different scientific communities. They can create data collections within the environment, and then they can easily share them among other groups. Also, you can create computational tools applications and place it in the environment. And similarly, these can be shared among groups. So you have this notion of I share data with you, you share a computational tool with me, and then we can collaborate. We can run tools, create derived data products, which is what Don is pointing towards in terms of analysis. And so these analysis have the feature that NSF was really looking at in the data nets. Okay, I need to wrap up really quickly. Basically, repeatable science, you can keep all the parameters, you can keep all the, and run repeatable workflows and share that derived data. And Tony, I need to leave you a little bit of time. Okay, this is Tony. Okay, so so in summary, you know, the interest stems back from the days of the DFC. There's a lot of work that they're doing right now to ease the pain of the deployment, so you can just stand up this infrastructure where you are, because CI is really hard. You know, and like a lot of these systems, we're challenging the scalability of the catalog, and they've had some interesting solutions about how to offload search and other activities from iRods out to different kinds of search technology. Dataverse, which Don also works with, is another very interesting platform. And Dataverse and Cyverse both are now looking at how to take their infrastructure built for a particular domain, either social science or plant biology, and trying to take that technology and extend it to other domains. So I hope, hopefully a lot of that sort of thing will continue. and the questions that we can ask about these systems is, what do these experiences tell us about how iRods fits, what it lacks, and what other pieces of the ecosystem are really necessary to build robust CI. So anyways, maybe I'm repeating myself from last time. Is there anything you want to say, Tony? No? Okay. That's it. Any questions?
So we've got questions for you guys. I've got a couple questions. I know this was a lot of work. I mean, this effort was largely to pull out and abstract the specificness of this deployment at Cyverse, because it was developed at Cyverse, to pull it into Community Edition, and now anyone can stand this thing up, right? That's the idea. So that was a lot of work. Took you how long to do that with all 5 smart people in a room?
A long time, because again, this is hard because it involves both computational infrastructure, identity management, and so forth. So we've managed to stand it up multiple times in multiple instances. I think that there's a lot of site-specific customization and honestly a lot of Docker networking and those kinds of things that was really difficult to do with things like Ansible.
Right.
So there was a lot of custom site-specific roadblocks we ran into originally doing this that involved more things like the network topology of the place you were installing it and how they used proxies and how that touched all kinds of different aspects of the system installation.
Right.
But they've since shifted to Kubernetes, which we're also generally interested in. And Don, maybe you can characterize how difficult, how painful it is now.
Well, what does a deployment look like now? If someone new sitting in the room who's never seen this wanted to play with it, what does that look like? How long does that take? How hard is it?
I haven't seen the permanent new Community Edition yet. In fact, the most recent instance that we stood up that has the Kubernetes services, Sarah Roberts stood up. We provisioned the VMs, we got things generally ready, and then they swooped in and did the config, and it turned out to be the beta installation for them. So we had that version before they did.
Oh, okay. You have a question? Here it comes.
Daniel Moore, and I've been working at Renzi for on the iRods consortium team with them for 5 months now, and I've been doing recently a little work related to Docker and data to compute to data, kind of reworking some examples we had, and I've been wondering if Docker, is Kubernetes like the definitive solution for getting Docker to work in high performance computing environment, or I mean, is that like the one way you can do that, or does Docker lend itself at all generally to high performance computing, or is high performance computing really what we're talking about?
I think what we're more interested in is the ability to move certain kinds of computation. So this isn't parallel compute that we're really interested in. I think projects like what Clarice is working on with SIDAS and so forth is more these large-scale compute jobs. What I think where it really shines is this notion of when you have large data sets and you can take a data extraction or some kind of data processing algorithm that's interested in subsetting data, and it's more about being able to have that portability to find where the data sits at rest. Take your Docker Singularity image and run it next to the data. So the notion that we're really pursuing is, for example, I take an app, the app discovers where that data sits on what we're calling a compute resource, like a special kind of iRod storage resource that just has Docker Singularity. It can locate that data and then schedule the container to run either by doing things like manipulating class adds and Condor or using some other scheduling. Map the data as a volume mount, as a read-only volume, run the Docker image there, and then stage the data back in the front door into iRod. So it's more about that efficiency of moving that computational unit to the data. And so it's not going to work in some cases, but there are many things like metadata extraction or NLP where it might work.
Since you mentioned Singularity, so you are using it? Or?
So at NIH, they very much prefer Singularity. So we're interested in, right now, workflow tools that can work easily with both. And we've actually found Nextflow, Deep is here. So for the stuff that we're doing, we found Nextflow is really good at being able to run either.
Nextflow?
Nextflow. We've played some with CWL because that's what the NIH Commons is talking about. But we, at least with Toil, we had some issues running Docker and Singularity with CWL. So we've kind of switched to Nextflow, and that's been pretty easy. So you can do these things. It can be fairly lightweight to do these things, but it's more that notion of moving the compute to where the data sits at rest is what we're. No. No. It's horses for courses. There's different tools you can use for different.
All right. Thank you so much.